Alex and Vanessa are going to talk about Roassal.
Hi. This is Vanessa. This is Camillo, and me, I am the happiest professor in the world, I think, to be surrounded by so bright students. So we've been working for like almost 1 year and a half on Roassal, and so I think we'd like to share it with you. So Roassal is an advanced visualization engine. So I say advanced because if you have heard about Mondrian, then you should probably want to try Roassal. In our opinion, is much better. Is much is well done. And yeah, so what is a visualization engine? So this is useful actually to draw a picture of your object. So as soon as you have a bunch of objects, then you can give them a visual shape on them. And Roassal is well modularized. It means that it is easily portable. It has been developed, and it is developed on Faro, and it works on VisualWorks. It works on VisualWorks 7.4 until the latest version. It also works on Number. And yeah, so Roassal has few external dependencies. So I mean that porting it is not very difficult as soon as you have a couple of libraries such as the announcement. And then it is open source. Yeah, so here an example. So here this is a visualization that shows you the class hierarchy of the collections. So at the topmost classes above, this is the class collections. And then it shows you which classes has the most methods, the most number of variables, and the largest lines of code. So we'll now run some examples, like small tutorials to show you how we can build this visualization. So the very first thing is you have to say in your view that you want some the subclasses of the class collections. So here you say view. In my view, I want some nodes, and those nodes are going to be given by sending the message with all the subclasses to the class collection. Then once you write that, then you will have those small squares that appears, and each square represents a class. And yeah, and then you can add the edges by saying that you will define the edges by sending the message superclass to each class, and then you will end up here some edges. Then in that current state is not really useful. You need to have a better layout. So this can be done by just writing the view tree layout, and then boom, you have a tree layout. So here at the top you will have the class collection, and then you see the group of classes that are subclasses of collection. Now, in the current state that all the classes they have the same size, a small square, then you can define a new shape by writing view shape. You want to have a rectangle, and you want to define the width and the height, and by sending the messages number of variables and number of methods to each classes. So now we will run the same thing but live. Okay, so Roassal is available in the Moose image. So once we have loaded Moose in your system, then you can go here, Roassal view. Oops. Okay, so it's going to be very small. Okay, so here this is where you write your script. So we say we want to have in the view all the subclasses of the class collections with all subclasses. Maybe we'll do it like this. So then I press Alt S, Command S, such as doing an accept, And here I have like my small squares, and each square is a class. So here this is the class hash tables, and here this is the class bitmap character set, and so on. You can add this. You can add the edges, view edges from superclass. And then here you have the same squares, but with some edges. You can zoom in, Then you can do a layout, view tree layout. And then you can define, a new shape. Saying you want to have view, shape, rectangle, the width, which is the number of variables, eighth number of methods. Boom, this is what happens. You can zoom out. Does it make sense to you? Or if you have any questions, then just raise your voice. Now we can give a bit of, okay, so now we see that almost all the classes, they have the same, more or less the same width, because this is the number of pixels, and since, there is not that many classes that have more than 5 instance variables, then we can amplify that. We can put that in a block. Boom. A block that takes into as an argument a class, and here we can put 10 maybe. Boom. And then here we see greater differences between the classes. We can add a bit of colors, linear fill color, saying this is the number of lines of code within collection with all subclasses. And then here you see the different, the darker the class is and more methods, more lines of code it has. So I won't really go into the details and justify this visualization. This has been done already by Michele Lanza and is in some famous paper. And yeah, I think that's, so there is a number of examples here as well. So yeah, we can do some kind of, we can have some edges with some arrows. We can even have something that looks like UML. There is really a lot of examples. So we have also the tree map layout, something that maybe, this is directly related to what Mircea has been showing today. I also have some choose layouts. Okay, but then also we have kind of animation. We can do that too. You see, it moves. Grid layout, circle layout, and yeah, here there is a tutorial. This is a tutorial that really shows what I've been doing so far. So then also there is a lower API that enables you to do some more fancy things, such as bouncing ball, and the code is rather small to do this. There is this one, this one here. You have usually, when we find an example in either in a website using JavaScript or in a magazine that shows some statistics, and we like to implement them. So here, those are some examples from processing, the library processing. There is this one as well. And yeah, so this one maybe as well. You can do some recursion between the different graphical widgets. And then we will show you the Amber version of it.
Amber version. I don't know if you know Amber. Is for making apps in client side. So you have a class browser, so you can build applications. In the left side you have packages, and then you can click and see classes, categories. You also have a transcript and a workspace. You can also run unit tests. So what we do is to build Roassal with Amber and being able to make the same visualization Alex showed, but in the browser. So for example, well, the layout is a bit messed up, but here you have a hierarchy. You can move the visualization, you can select one, and I'm going to do the same kind of visualization Alex said.
No, es Shift. ¿Para hacer eso?
No quiero avanzar hasta ahí.
No sé cómo se hace. Sorry, this is my laptop, and we didn't want to switch laptop actually. Yeah. Doesn't work.
Quiero hacer
El cosito.
Sí.
Yeah, sorry. Aquí that's true.
Sí.
Yeah, aquí
Okay.
demuestras un ejemplo.
Yeah, I better show an example.
Yeah, so sorry about that. You know, I have a strange keyboard layout and.
Yeah, I'm not used, sorry. But the idea is the same. You write a script here, and you will see, click in generate view, and you will see the result of the script in this canvas. So I'm going to show you examples. So I have the same layout Alex showed with the examples. For example, I will show this one, lines. You have interactions, you can move it. You can also have interactions with the menu, like you do right click in each of these nodes, you do right click. Well, sometimes you do right click. You have the pop-up view. This is a node, and if you put the mouse over the node, you have the hierarchy of the collection, which is the node. But the idea is not only have an easel, a structure, and you can build any kind of visualization using Amber. So, for example, you can do grid. You can evaluate, and you have an independent visualization. Very easy. And the last one I want to show you is a little animation. I hope it can be seen because of the layout. But
Yeah.
sorry.
Yeah, we were a bit trapped by the small resolution of the screen.
Sorry.
So
Maybe it didn't have the same visualization you have in Faro, but in the browser, and very independent, have animations, have layout, and all the same stuff.
Okay, so here this is the structure of Roassal. So here we have, at the bottom here, you have your platform, which could be like Faro, VisualWorks, or Ember. And soon we'll have like Visual Edge, Smalltalk. At the top you have Roassal. Then at the top of Roassal you have a small domain-specific language, the one of Mondrian. And then your application can use either Mondrian or Roassal or both at the same time. And without going too much into the detail, but an element in Roassal, graphic element, looks like this. So here you have the element. Element knows what are the different interactions you can do on it, like what are the different callbacks that an object should answer when you press a key or when you click on it. And then you have like a list of shapes, and these shapes, this list of shapes could be a box with a text in the middle and a border in surrounding. So like people have been using Roassal a lot recently. So there's been like plenty of applications. So I've seen one with, in the talk of Mircea, there is several others. So we would like to show you like 2 applications we've been working on. So the first one is called the profiling blueprint. So we like to do dynamic analysis. So here this picture is the result of a profile. And this is something much better, I think, we think about than message steady, the classical standard code profiler. So here, like each method is a square. So you have the method A, which is at the root. So this is really the root of your execution. And then you have like a graph of methods that are invoked directly or not by the class A, or the method A. And each method has a size and a color. The height of the method is the time spent in the method. The width is the number of times the method has been executed. And then the color, the yellow color, tells you like whether the method does a side effect or not. A yellow color means there is no side effect. So something interesting with this kind of visualization then is a very gives you like hints on where to introduce caches. So here we have like an example of 2 very large yellow methods. It means that those methods that takes time because they are very very tall. And those methods they have been executed like many times because they are very wide. And since they are yellow, then they don't do a side effect. And the very cool thing is that once you know that, then you can easily introduce a cache. So here the source code of this method f here is this one, which actually belongs to Roassal. So we are using Roassal to profile and enhance Roassal itself. So this is kind of cool. So here we have the method bounds that just give you like the rectangle that describe the bounds of a graphical object. Then you know that this method is executed many times and it takes a lot of time. So you can just introduce a cache like this. I'm just summarizing, but this is really the idea. And by introducing this method here, then if you execute your application again, your benchmark again, then you have a new version here without this large method. And yeah, so we've been using this profiler to obtain this kind of blueprint. So here we have a version that contains a lot of large and thick yellow methods. We introduce some caches, we obtain these versions, and so on. When we reach that level here, and there is not much optimization you can do without changing the architecture of your application. Yeah, so it's not only that we like to program, but also we are researchers. So there is a number of papers that are associated to this picture, and and we like to target really the most prestigious conferences and journals. And the second application we like to show you is called Loom. Yeah.
Okay, so Loom is a tool we're working on, and not complete yet, but the idea is like a web monitor, using Roassal in VisualWorks. Well, it also works in Faro. So you have a list of all the threads, and you have two panels. In the left side, you have options. If you select a particular thread, you have a lot of options like inspect the thread, see the ID, the process name, etc. You can also terminate there. You can inspect profiler and a lot of other things. And in the lower panel, you have the evolution of the total amount of CPU consumption. And you can select one thread and be the particular evolution of it. So you will see in the bottom a little green line which shows the evolution. So for example, if I select the workspace, and I do some stuff, I will see the thread of the profiler will start to grow up and go down. So that's the idea. You have filters of the list and well, the typical stuff. But the idea is that you are using Roassal in VisualWorks and for different kind of applications.
Yeah, so at the very beginning, we had this here, like the standard VisualWorks button, but actually we were not happy with that. Then we just removed them and use the UI made in Amber, in Roassal. Okay, and then there is also an application that Camille is going to show you, and this is really cool. So the idea is that visually, the idea is, as you know, to every object you can send the message inspect, and the idea of visually is to send the message visualize to any object. So Camille is going to show that later on, and this is really cool. So now we'll do a bit of self-advertisement. Okay, so we are based in Chile, and we have a number of positions like internship, engineering position, master position, and PhD position. So there is a deadline running at the end of this month for applying for the PhD. For the master, I don't know, but for the PhD at least there is a deadline. So I know that some of you are interested in that, so please come to talk to us like soon. And yeah, Santiago is a really cool city. I mean, you have these huge, mountains in front of your nose. This is really cool. And something else really great that there is no mosquitoes at all. Amazing, amazing. Sorry? There is smoke, yeah, a bit of smoke, but then there is no bugs, there is no cucarachas. So, it's really cool, really cool. And yeah, so this is what I think what we had to say. So here, this is like some of the link. We have a Facebook webpage, so I see a lot of people with laptops. Click on like. Go there, click on like. We have also Twitter, just follow. This is good. One day when we apply to some grants, people like to see this kind of metrics. And yeah, so thank you very much.
How hard was to migrate the code to Amber? Did you have to change the way?
Kind of. Just Amber has some different stuff like they are not, so you have to remove some of them. But after that, you can just file out and just add it to the code view in the browser, and that's it. You have to do some switch because you don't have threads, so all the animation have to switch the way they were doing in Faro. You have to switch some stuff like math, how to access to P and stuff that is different in Faro, and that kind of stuff.
What about the visualization?
Actually, yes. It was a bit hard because the regular canvas was extremely slow, really, really slow. So for now, what we're using is the GS version of processing. So we like plug it, and we are using processing for the frame refresh and the rectangles and all the stuff on the regular canvas, but not the low-level APA.
You told us you had no threads in Calendar. Have you
Sorry, again?
No. Have you tried what workers? It's developed for Chrome and allows you to run background processes.
Like
share nothing but you run code while your main project may be rendering the screen or something like that.
Sorry, let me know if I understand. Well, workers for threads, right? For having, yeah. Just, I'm not sure if I tried that one, but I think it was that one because it's the most famous, right? Yeah, I tried, but I wasn't able to plug it to Amber and actually connect it completely to work with Roassal and Amber. So I tried, I wasn't able, but when I was searching, I found it. But
Thank you.